Subscribe to Knowledge Hub, like this video, and tap the bell so you never miss what's next.
Welcome back, deep learning developers and AI enthusiasts. Today, we're diving into the high-level neural networks API that made deep learning accessible to everyone, Keras. If you've ever felt overwhelmed by the complexity of building neural networks, Keras is about to become your new best friend. In this video, we'll explore how Keras democratized deep learning, making it practical and approachable for developers everywhere. Whether you're a beginner or an experienced practitioner, you'll discover how Keras can simplify your workflow and empower your creativity. Let's get started on this journey to make deep learning truly for humans. Keras was created with a simple but powerful philosophy. Deep learning should be accessible, intuitive, and fast to experiment with. Unlike other frameworks that required complex code and deep theoretical knowledge, Keras provided a clean, simple interface. This allowed developers to focus on their ideas, rather than getting bogged down in implementation details. Think of Keras as the Python of deep learning. It's designed for human beings, emphasizing readability and rapid prototyping over complex optimization. This human-centered approach is what sets Keras apart and has helped it gain widespread adoption in the AI community. At its core, Keras is a high-level neural networks API written in Python. It can run on top of TensorFlow, Theano, or CNTK, enabling fast experimentation with deep neural networks. Keras is user-friendly, offering a simple and consistent interface. Its modular design lets you build neural networks as sequences or graphs of modules, and it's easily extensible, so you can add new components as needed. Originally, Keras was a standalone library supporting multiple backends, but it has now become the official high-level API for TensorFlow, known as tf.keras. Its vision remains unchanged: to make cutting-edge deep learning accessible to as many people as possible, regardless of their background. Keras stands out for several key characteristics. It's user-friendly, offering a simple and consistent interface that makes model building straightforward. Its modularity means you can assemble neural networks, like building blocks, snapping together layers and components as needed. Keras is also highly extensible, allowing you to create new modules, layers, and metrics with ease. Being Python native, it integrates seamlessly with the broader Python data science stack, making it a natural choice for developers already familiar with Python. These features collectively make Keras a powerful tool for both beginners and experts in deep learning. Keras began as a standalone library that supported multiple backends, including TensorFlow, Theano, and CNTK. Over time, as TensorFlow became the dominant deep learning framework, Keras was officially adopted as TensorFlow's high-level API. This integration, known as tf.keras, brought Keras's simplicity and user-friendly design to the broader TensorFlow ecosystem. Despite this transition, Keras has maintained its core philosophy of accessibility and ease of use. Today, it remains a vital tool for anyone looking to build and experiment with deep learning models quickly and efficiently. Keras quickly won the hearts of developers and researchers thanks to its simplicity and readability. Traditional deep learning frameworks often required verbose and complex code, but Keras made it possible to define models in just a few lines. This clean and intuitive approach allowed users to focus on their ideas and research rather than wrestling with implementation details. Rapid prototyping became a reality. Models could be built in minutes, not hours. This shift empowered students, researchers, and companies to innovate faster and more effectively. Keras is built on 4 key principles: user-friendliness, modularity, easy extensibility, and being Python native. User-friendliness means intuitive APIs that lower the barrier to entry. Modularity allows you to build models as if you're snapping together Lego blocks, making experimentation easy. Easy extensibility means you can create new layers, metrics, and more without hassle. And being Python native ensures you can work with familiar tools and libraries, avoiding the need for complex configuration files. These principles have helped Keras democratize deep learning for a wide audience. The result of Keras's philosophy and design is the democratization of deep learning. By lowering the technical barriers, Keras has enabled students, researchers, and companies to build sophisticated models with minimal code. This accessibility has accelerated innovation and made deep learning a practical tool for a much broader community. Whether you're working on academic research, industry projects, or personal experiments, Keras provides the tools you need to turn your ideas into reality quickly and efficiently. At the heart of Keras are layers, the fundamental building blocks of neural networks. Layers can be dense, fully connected, convolutional, recurrent, or specialized for tasks like dropout and normalization. Each layer transforms its input data in a specific way, allowing you to build complex models by stacking and connecting different types of layers. This modular approach makes it easy to experiment with different architectures and find the best solution for your problem. Keras offers several ways to organize layers into models. The sequential model is the simplest, stacking layers in a linear fashion. For more complex architectures, the functional API allows you to define models as directed acyclic graphs, supporting multiple inputs and outputs. For maximum flexibility, you can use model subclassing to create entirely custom architectures. This versatility means Keras can handle everything from simple experiments to cutting-edge research models. The sequential API is the easiest way to get started with Keras. You simply stack layers in order, and Keras handles the rest. For example, you might start with an input layer, add a few dense layers with activation functions, and finish with a softmax output layer for classification. This approach is perfect for beginners and for quickly prototyping ideas before moving on to more complex architectures. For more flexibility, the functional API lets you define models as graphs of layers. You can create models with multiple inputs and outputs, share layers, and build nonlinear architectures. This is essential for advanced research and real-world applications where simple, sequential models aren't enough. The functional API maintains Keras's simplicity while unlocking powerful modeling capabilities. The typical Keras workflow starts with defining your model. Using either the sequential API or the functional API, you specify the layers and their configurations. For example, you might create a model with dense layers, dropout for regularization, and a softmax output for classification. This step is all about translating your ideas into a concrete neural network structure. Once your model is defined, the next step is to compile it. This involves specifying the optimizer, loss function, and metrics you want to track during training. Keras makes this process straightforward, allowing you to focus on the high-level design of your model rather than low-level details. Compiling prepares your model for efficient training and evaluation. Training your model is as simple as calling the fit method. You provide your training data, specify the number of epochs and batch size, and optionally include validation data. Keras handles the rest, managing the training loop, updating weights, and tracking progress. This simplicity allows you to iterate quickly and focus on improving your model's performance. After training, you can evaluate your model's performance on test data using the evaluate method. Keras provides clear metrics like accuracy and loss, making it easy to assess how well your model is doing. You can also use the predict method to generate predictions on new data, enabling you to apply your trained model to real-world problems. Keras makes it easy to save your entire model, including its architecture, weights, and optimizer state. You can save your model to a file and load it back later for further training or deployment. This feature is essential for production workflows and for sharing models with others. With just a couple of lines of code, you can preserve your work and pick up right where you left off. One of Keras's strengths is its built-in training loop. This loop handles automatic batching, manages epochs, tracks progress, and supports validation during training. You can also use callbacks to customize behavior, such as early stopping or saving the best model. These features make training efficient and flexible, allowing you to focus on model improvement rather than boilerplate code. Keras provides a powerful callback system that lets you customize training behavior. For example, you can use early stopping to halt training when performance stops improving, or model checkpoint to save the best model during training. Callbacks can also be used for logging, learning rate scheduling, and more. This flexibility helps you optimize your training process and prevent overfitting. Keras includes built-in pre-processing layers for tasks like normalization and text vectorization. These layers can be integrated directly into your model, ensuring that data pre-processing is part of your workflow and can be exported with the model. This approach streamlines the pipeline and reduces the risk of data leakage or inconsistencies between training and inference. Transfer learning is a powerful feature in Keras. You can load pre-trained models like ResNet 5.0, add your own custom layers on top, and fine-tune the model for your specific task. This approach leverages existing knowledge from large datasets, reducing the amount of data and time needed to achieve high performance. Transfer learning is widely used in computer vision and natural language processing applications. For advanced users who need more control, Keras supports custom training loops. By using TensorFlow's gradient tape and custom training steps, you can implement specialized training routines, custom loss functions, and unique optimization strategies. This flexibility ensures that Keras can handle even the most demanding research and production requirements without sacrificing its user-friendly interface. Keras offers a wide range of pre-trained models for computer vision tasks. These include image classification, object detection, image segmentation, and even image generation. With just a few lines of code, you can load models like ResNet 5.0, VGG16, or MobileNet, and apply them to your own datasets. This makes state-of-the-art vision models accessible to everyone. Natural language processing is another area where Keras shines. You can build models for text classification, sequence-to-sequence tasks, transformer architectures, and text generation. With built-in layers and pre-trained models, Keras makes it easy to tackle complex NLP problems, from sentiment analysis to machine translation. Keras isn't just for images and text, it also excels at structured data tasks. You can use Keras for tabular data analysis, recommendation systems, time series forecasting, and anomaly detection. Its flexibility and integration with the Python ecosystem make it a great choice for a wide variety of data science applications. Keras supports a variety of specialized architectures, including autoencoders for dimensionality reduction, GANs for generative modeling, VAEs for probabilistic modeling, and Siamese networks for similarity learning. These advanced models are essential for cutting-edge research and are made accessible through Keras's intuitive API. Keras is deeply integrated with the TensorFlow ecosystem. This means you can leverage TensorFlow's distributed training, GPU and TPU acceleration, and advanced deployment options like TensorFlow Serving, TensorFlow Lite, and TensorFlow.js. Keras models can be visualized with TensorBoard and deployed at scale, making them suitable for both research and production. Keras offers robust production features, including model serialization and versioning, distributed training strategies, and monitoring and logging. These capabilities ensure that your models are not only easy to build and train, but also ready for deployment in real-world applications. With Keras, you can move seamlessly from research to production. Getting started with Keras is easy. Since it's included with TensorFlow, you can install everything you need with a single command: pip install TensorFlow. The official documentation, website, and community resources provide a wealth of examples and guides. Whether you're building your first model or exploring advanced features, Keras offers the support you need to succeed. A classic Hello World example in Keras involves building and training a simple neural network on the MNIST dataset. You load the data, flatten the input images, add dense layers with activation functions, and train the model for a few epochs. This hands-on approach helps you quickly understand the basics of deep learning and see results in minutes. To get the most out of Keras, follow best practices. Start simple with the sequential API. Use callbacks for early stopping and checkpointing. Monitor training with TensorBoard. Validate early to catch issues. And regularize your models with techniques like dropout. These habits will help you build robust, high-performing models and accelerate your learning process. There are plenty of resources to help you master Keras. The official Keras documentation and guides are comprehensive and beginner-friendly. The Keras.io website features numerous examples, and books like Deep Learning with Python by François Chollet provide in-depth insights. Online courses and tutorials are also available, making it easy to find support and inspiration as you learn. Keras has succeeded in its mission to make deep learning accessible to everyone. By providing a clean, intuitive interface while maintaining the power and flexibility needed for cutting-edge research, it bridges the gap between simplicity and sophistication. Whether you're a student, researcher, or industry professional, Keras gives you the tools to turn your deep learning ideas into reality quickly and efficiently.
Subscribe to Knowledge Hub, like this video, and tap the bell so you never miss what's next.